Now that we've defined sets, we can talk about functions. So let's fix a set A and fix a set B. Then we'll define a function f. So the definition of a function is an assignment of exactly one element of B to every element of A. So for example, if A is the set 1, 2, 3, and B is the set 4, 5, 6, then here's an example definition of a function. We have to assign one element of B to every element of A. So we need to write down what f of 1 is, what f of 2 is, and what f of 3 is. So f of 1, well, we can pick any element of B that we'd like, so let's just choose 4. F of 2, let's say that that's 4 again. And f of 3, let's assign that 6. So this is a valid function, f, because it is an assignment of one element of B to every element of A. So f of 1 is 4, f of 2 is 4, f of 3 is 6. And we say that 4 is the image of 1 because 1 gets mapped to 4. You could also say 4 is the image of 2, and 6 is the image of 3. Now here is an invalid way. This would not be a function. If I said f of 1 is 4, and then I tried to also say f of 1 is 5. Nope, this is not a function. When you want to specify f of 1, you get to make one choice. You don't get to make two choices. So you can't write f of 1 equals 4 and f of 1 equals 5. You can only say f of 1 equals something. In this case, we've chosen 4. A is called the domain. Excuse me. So A is called the domain of the function, and B is called the codomain. Okay, so in this case, the domain of the function is 1, 2, 3, and the codomain is 4, 5, 6. Notice that 5 was not mapped to by this function. That's okay, it doesn't have to be. Functions are also called, since I've used the word map, functions are also called mappings. So if I say f is a mapping, it means the same thing as saying that f is a function. Now we could say, does the element 4 have a pre-image? And we could say that yes, the element 1 is a pre-image of 4. Turns out that the number 2 is also a pre-image of 4, because 4 is mapped to by both 1 and 2. So it's okay for elements in the range to have multiple pre-images, as we've seen by this definition of f. We can also define the range of a function. So the range of a function f is equal to the set of all f of x such that x is in A, the domain of the function. So in this case, the range of f is equal to the set 4 and 6, because we can see that 4 gets mapped to and 6 gets mapped to. 5 never gets mapped to, so 5 is not in the range of f. We can also say that two functions two functions f and g are equal if f and g have the same domain and codomain, so f and g have to have the same domain and codomain, and for all elements x in the domain, f of x should equal g of x. Now we're used to seeing functions in terms of numbers. For example, in your calculus class, I'm sure you're familiar with functions of the form f of x equals x squared, or maybe f of x equals log x. But functions are a far more abstract concept. So for example, we could let a range A be the letters D, E, and F, and we could let a set B be the days of the week: Monday, Tuesday. Okay, and so we could have a function g that maps D to Tuesday. G, we have to specify what E gets mapped to. E goes to Monday, let's say, and we could say that F goes again to Tuesday. So again, we have to assign one value of B to every value of A, and they don't have to be numbers. We could have a function H, or we could let A be the set of all graphs on n, or let's say 100 vertices, and we could let B be the set of natural numbers, and we could define F, let's call it H. We could let H be a function that takes in an element of A, so it takes in a graph, and it outputs the chromatic number of the graph. So here we have a function H. It's taking in some graph on 100 vertices, G, and the assignment that H gives to G is the chromatic number of that particular graph, which is going to be an integer. So it's going to be, in fact, it's going to be a natural number. So it's mapping from the set A to the set B.